All right. So last time, what we end up talking about? And they were talking about interrupts. Okay. Um, Did I give anybody like something to remind me about? Nope. So we'll just keep going then. So dealing with I/O structure. I/O starts, control returns to the user program only upon I/O completion. So that's kind of what we were talking about last time, where when your CPU is cooking, and we'll talk about that in more detail when we actually talk about CPU management, and is working on a particular program, and when that program gets a request for I/O, it'll get interrupted. That way, it's not sitting taking up that resource that is your CPU when it's actually waiting for the user to enter something in or click something or something like that. Because we want our CPU to run as close to 100% of the time as possible. Now, so that's the goal of our operating system from a CPU management perspective. Is we want our CPU to be busy as close to 100% of the time as possible. What do you think the average idle time for a CPU is? What percent of the time do you think your CPU sits there doing nothing on your computer? Ish, on average.
30%.
Remember, the goal is to keep it busy 100% of the time.
30%.
So you think 30% of the time it's sitting there doing nothing? Any other guesses? That's low. Huh? 90? Okay. What do you think? Do you think it's high or low? His number's low.
Wow.
Probably about 96 to 97% of the time, your CPU is doing nothing. So now wait a minute. The goal of the operating system is to keep the CPU busy 100% of the time. Yet, in the high 90% of the time, the CPU is doing nothing. How many of you have built your own computer? I know I've asked this several times. Okay, how many of you went out and bought the latest, greatest, fastest, most expensivest processor? See, the recording doesn't catch the air quotes. It just thinks I'm bad at. So you went out and bought the quad-core i7, fastest clock speed you can get. None of you did that? How many of you bought the fastest processor you could reasonably afford? Okay. Could you have possibly spent that money elsewhere?
Sure.
And go one or two steps down? When people build a computer, my recommendation typically is, if you look at CPUs, there's going to be a point where you see a CPU at this price point, and the very next model up jumps substantially. So it's like fairly cheap, relatively speaking. So going from this processor to the one next to it is not that huge of a jump. Probably makes sense. But when you decide to make that jump to go from 2.9 gigahertz to 3.06 gigahertz, and it doubles the price of the processor, waste of money. Especially given what I just told you, that the processor sits there idle 95% of the time. So why do they sell the faster processor? Why do we need faster processors? How many of you have ever made the decision to get a quad-core processor over a dual-core processor? You buy a laptop, you had the choice to get a dual-core i5 or a quad-core i7. Well, quad-core must be better than a dual-core.
4 cores.
Yeah, I mean, 4 is better than 2. Is that true? Are you better off getting the 4 cores?
Apparently not.
Well, I haven't given you an answer yet. Remember, I trick you. Like it's Doctor Who, the doctor lies. So, Yeah, see, actually, that's a more humble statement. Comparing myself to Doctor Who. Last year, I compared myself to Yoda.
You also compare yourself to Meatwad.
I do. No, I speak like Meatwad. I don't compare myself to Meatwad. So is a quad core better than a dual core? What does it mean to be a quad core or a dual core? What does the number of cores mean? Or is it just one of these buzzwords that, well, core sounds cool.
Is it 2 or 4 processors?
2 or 4 processors, okay. What does more processors mean? If one brain is sitting there idle 95% of the time, what the heck is 4 brains going to do?
The other 5% of the time they're going to work really well.
Okay. What does it mean to work really well? Will a quad core processor always be faster than a single core processor? Or let's just talk in today's world. Will a quad core ever always be faster than a dual core?
No.
Okay, why not?
Not everything utilizes it. Not everything will utilize all 4 cores.
Okay, what does it mean to utilize all 4 cores?
Actually,
Like how would something take advantage of 4 cores rather than 2?
You do 4 things at the same time instead of 2 things at the same time.
Okay, so more processors mean the more individual tasks you can do simultaneously. Fair enough? So if you have 4 processors, you can literally do 4 things at the exact same time. Keeping in mind that one of the goals of the CPU is to trick us. That is, CPUs are really, really, really fast. So even a single core CPU, which you can't buy anymore, but even a single core CPU, it could do 10 things. Even though they're not happening simultaneously, it can do them so quickly to the end user, they might perceive it to all be happening at once because it's doing them so quickly over and over and over again. Does that make sense? Switching from one task to another. It's cleaning the kitchen, then it's making up the bedroom, then it's doing the laundry, but it's doing those little bits at a time really, 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 really fast. Okay? So in a multiple core situation, if you have the job if you're a quad core and you have the job of cleaning the kitchen, cleaning the bedroom, and doing the laundry, you could do all 3 of those things simultaneously and have one more task to spare. You don't have to switch between them, right? Because those are mutually exclusive jobs. You can be cleaning the bedroom and cleaning the kitchen at the same time. Those 2 don't conflict with each other. Does that make sense? But let's say you're solving a math problem. Math problems are often linear in nature in terms of how you solve them. Can you do step 3 of the math problem before you do step 2? Usually not. Usually step 3 is reliant on the result from step 2, correct? So you might have extra cores sitting there ready to do work, but there's no work to give them because the problem you're currently solving doesn't require or isn't compatible with more workers. Kind of like the old joke, how many people does it take to change a light bulb? You could have 1,000 workers, and they're not going to change a light bulb any faster than 1. Really, you only need 1 person to change a light bulb. But the example I like to use is, let's say you're cleaning up the trash in a park. Okay, and you have 1 person who's going to clean up the trash in the park, or you have 4 people that are going to clean up the trash in the park. Which group is going to pick up the trash quicker? Well, if we're talking about people, probably the group of 4, right? Because we have a kind of a perceived speed at which people can pick up trash. We kind of think about that in our head. And we think, there's no way that 1 person can be so fast at picking up trash that they can keep up with 4 people. Unless those people are like infants, right? Just kind of park them near they're just going to sit there and drool. Okay, but generally speaking, 4 people are going to pick up the trash in a park faster than 1 person can pick up the trash in the park. All right, good enough. Now, what if that 1 person, so let's kind of move this to the computer world. Let's say the 1 person is so fast at picking up trash. They pick up trash at 3.06 gigahertz, whatever that means. Now, the other 4 people are much slower. They can only pick up trash at 2.23 gigahertz each. Who's going to win? One dude at 3.06 or 4 dudes each operating at 2.23? It's going to be closer, but those 4 dudes are going to pick it up substantially faster. It won't even be close. Okay? It'll just be closer. All right? So, when a problem can be divided into different jobs, multiple cores shine. When a problem cannot be subdivided, a faster single core shines. Make sense? Okay. Now, why is it that our processors for a single core have not been getting faster? Have you noticed that? Over the last several years. What's the fastest single core processor you can get today? I mean, I know you're buying dual or quad core, but each of those cores has a speed. 3.06? Something like that?
Sure, AMD, let's go to 4.
Okay. And that gigahertz rating only means so much because it really is dependent on the architecture. So a processor running at 4 gigahertz isn't necessarily faster than a processor running at 3.06 gigahertz if they're not the same architecture. If they're not the same product. Okay? One of them might leverage that speed differently. There's a thing called a clock multiplier. But let's just think we're talking about Intel compatible, we'll just say they're the same architecture. Reasonably speaking, the fastest we've seen from Intel has been 3.06, right? Doesn't it actually shed a little light on the problem if they're measuring it down to 0.06? Because for a while it was at 3 gigahertz. Now it's at 3.06. They were able to squeeze a little bit more speed out of it. Now, is a 3.06 processor, is it really different than a 3.0 processor? In many cases, it's the same guts. Those processors have to be tested up to a speed. How many of you have overclocked a processor? So you used to have to do this on the hardware. You go into the motherboard and mess with jumpers. Jumpers don't exist anymore. You used to mess with jumpers and say, okay, well, rather than running this, so going back to old a 300 megahertz processor, long time ago, 300 megahertz processor, you could do a 100 megahertz front side bus with a 3.0 multiplier to get to a 300 megahertz processor. Well, what some people would do is they try to overclock it. They would do, so some motherboards were built for overclocking. So they would have a front side bus of 105 as an option. So you could actually get an extra 15 megahertz out of that. At what cost? What's the risk of overclocking a processor? Heat, right? That processor isn't rated to be able to handle the heat that comes off of running it at that clock speed. Well, that's a true story. Yeah, if you haven't. How many of you haven't heard that story? Oh, really? When I was an undergrad, guy down the hall was big into overclocking processors, and a famous processor that was very overclockable was Intel's. It was one of their budget pleaser chips called the Celeron. He had an Intel Celeron processor. I think the chip was rated at 233 megahertz. And this guy overclocked it to like 1.1 gigahertz. And when you overclock, a lot of times, when you buy these gaming machines and stuff like that, Alienwares are typically actually overclocked by default, but they have all sorts of liquid cooling stuff in them and things like that. So it's not a big deal. So, well, back then, liquid cooling and things like that didn't exist. You know, the people that were hobbyists with overclocking, they would, you know, things you would read about were like dipping your entire computer in a bath of liquid ether, which is an inert liquid, so it wouldn't, you know, electricity wouldn't flow through it, but that was supposed to be a good coolant. So this guy had his case open, and he had all these fans just blowing into the thing, and just, you know, every single little, you know, wives' tale he read about cooling a processor he had going on in there. So like one morning, it was like, I don't know, 3 or 4 in the morning or something like that. It was in the middle of the night. He runs down to my room. He's at one end of the hall. I'm at the other end. And he runs down to my room and says he wants me to come look at something. So I come out of the door. There are flames billowing out of his dorm room. Okay, his entire room is on fire. I mean, not like, oh, there's some heat in, you know, no. You take, what is it, a 10 by 10 foot room, and you fill it with fire. That's what was going on at the end of the hall. This guy's whole room was torched. And apparently he like stayed in there for a little bit. So like, he was trying to put it out or whatever. So yeah, so he literally just burned his whole room down. His room was uninhabitable the rest of the semester. Everything in there was lost. So yeah, so that was an overclocking story.
Did he overclock it again?
Yeah, he did. So, I guess interesting thing. So overclocking, I guess, do with care, but also understand what we've already talked about here, that most of your time your processor is sitting there idle. So when do you think your processor is not sitting there idle? When is it working at 100% capacity? You have a quad core, maybe when you have 4 programs open. So you get Microsoft Word, use your email, get a web browser, Photoshop, okay? Get 4 programs open. Is it working at 100%? It's working at 100%, about 5% of the time. Because those programs are only so demanding. I mean, Word is sitting there doing nothing. Like right now, we're running Keynote. It hasn't done anything in many minutes. It's just sitting there. I've made no requests to this program. My processor's not doing crap. Okay, and this is a core a 4-core i7, sitting there doing nothing. So when is our processor doing stuff? What kinds of tasks take advantage of those multiple cores? How many of you have a computer that has more than 4 cores in it? I know AMD makes a 6-core processor. Any of you have like a dual quad-core or a dual 6-core processor? Actually, doesn't AMD make an 8-core? None of you? So none of you idiots who went and spent zillions of dollars on a processor or a graphics card or anything like that bought dual processor, multiple core CPUs? Just for bragging rights, right? I got a guy in another class who's got 32 gigs of RAM. You have 32 gigs? In what, your laptop?
Yeah.
That machine has 32 gigs of RAM in it. Why?
Virtual machines.
It's not going to help.
Having multiple virtual machines running at the same time.
Yeah, you're still going to max out your processors.
Debatable.
It's not debatable.
If you're running
you're gonna allocate when you run virtual machines, you're gonna allocate resources. So you have a collection of resources that are your laptop.
Yeah.
And you're allocating those resources to each running virtual machine. So you have plenty of RAM. So you can have 4 gigabytes of RAM allocated to every one of your virtual machines and have several virtual machines running, right? Your RAM's not your problem.
No.
Okay? How many cores processors do you have?
It's
Do you have a dual or a quad core?
probably Probably.
If it's a dual core, it's going to be really embarrassing, this example.
Probably quad.
Quad core? Okay, so you could have 4 virtual machines running at once, giving each of those virtual machines one of your cores.
Yeah.
So you have 4 virtual machines that you can run simultaneously, giving them a full single core of your CPU. But you can manage many more virtual machines than that with RAM. So you have more RAM than you can effectively use.
Not if you're using that much RAM on a single virtual machine, though.
Well, okay, so you can divide your.
If you're using huge SQL servers that contribute 16 gigabytes per virtual machine, then.
Oh no, certainly. The RAM is going to be beneficial for virtual machines. If you want to run 2, let's say you want to run 2 virtual machines.
Yeah.
So you can run 2 virtual machines simultaneously, give each one 2 processors, and give each one 16 gigs of RAM, and you'll have pretty solid virtual machines. But your virtual machines are far more capable from a RAM perspective than they are from a CPU perspective.
Oh, sure.
Right. So, the 30, I'm not sure 32 gigs of RAM is going to be any better than 16 gigs of RAM than that, even if you're running databases. But certainly you have an abundance of one resource, and your other resources don't come anywhere close to keeping up to that because you have so much RAM.
Yeah.
So I think it could be argued that 32 gigs of RAM is not necessary in any consumer computing model. Now, having said that, it's good bragging rights, right? It's like 32 gigs of RAM. You got dual 8-core processors. You got 16 cores, and each one has hyperthreading, so it's really effectively 32 cores. What's going to use 32 cores? Some things would.
Servers.
Well, not necessarily. A server is just a very blanket term.
Okay.
Certain tasks. Okay, using multiple cores is really a task-based thing. So, for instance, down the hall here, we have a Mac Pro. So we have a dual quad core. So it's an 8-core Mac Pro, one of the new ones, with an unusable monitor. For you in yesterday's class, and that saw that in the architecture class, we went down and looked at a 32-inch 4K monitor. It was like difficult to look at, right? Latest, greatest, coolest, most expensivest monitor you can buy is basically unusable. It's too high resolution for a human being. Everything was so tiny. We had to have multiple stops with the mouse to get it from one side of the screen to the other. The mouse pad wasn't big enough to keep picking it up. So what kinds of tasks would somebody condone buying a machine like that? So an 8-core in each one of those is hyperthreading. So we have 16 effective cores in that machine down there. 16. We can do 16 things at once. What kinds of tasks would make that worthwhile? People use those, right? So what do you have? You have some of the people that use those who actually need them. And you have some of the people that use those who do it for bragging rights. It's like, yeah, I dropped 10 grand on my computer. Doesn't run any faster for the stuff I use it for than your MacBook Air. It's got 32 gigs of RAM, and I put a riser on there, so I'm actually running 64 gigs of RAM. It's a new thing. I got it from Italy. Ever met one of those people? Just talking about all these modifications they made to the computer. It's cool bragging rights, right? But they're like, you're not going to use it. It's completely insane. But it sounds really good on paper, though. So I had one of those beasts as a server at our last school. I actually named it Toolman. That was the name of the server. Tim the Toolman Taylor. Get it? Toolman was the name of the server. Oh man, we just threw everything in. We had that was back when AMD had a processor called the Optron. It wasn't their Athlon processor. It was the server class processor at the same time. But they were really expensive. Really, you didn't need them processors. But we had those. It was cool. It was awesome. So what kind of task would somebody have to be doing in order to legitimately condone the purchase of one of these high-end, Dell servers with a bunch of cores in it, or a Mac Pro with a bunch of cores in it. Okay. Video editing would be a good example. Which part of video editing really benefits from it? Encoding. So how many of you, if you ever, certainly you're downloading a perfectly legitimate large video, right? Not a first run screener DVD rip, right? Not one of those. Perfectly legitimate video, and it just happens to not be in a format that you can conveniently watch on your big screen TV. Because you're streaming, you're using your Xbox for streaming, whatever it is, and you have to convert it to another format. Okay? So you have your 2.5-hour movie. Let's just say it's the latest Spider-Man movie. The day before it came out in the theaters. As an example. All right? So you got this 2.5-hour movie, you downloaded it, let's say it was a 5 gigabyte download or something like that. Whatever. And now you need to convert it to a different format. You probably got it in some sort of, weird Russian codec. Because the thing had, was in the Russian language with, Korean subtitles. You didn't know that at the time. Okay. Just, as an example. As an example. So, now you need to convert this video so you can watch it through your Xbox or whatever. Now, let's say you're using a standard, run-of-the-mill laptop, probably a dual-core, 2.0 gigahertz processor, something like that, maybe a 2.4 gigahertz processor, somewhere in that ballpark. How long would it take you to convert that video from Russian codec to something usable like for Xbox Windows Media Player? What would be the conversion time? 5 minutes? 20 minutes? 3 hours? We're getting closer now with the 3 hours, right? On a standard laptop, a 2.5-hour movie might take 2 or 3 hours. A good chunk of time, right? Now, if you were to convert that same movie on that Mac Pro down the hall, probably be done in about 8 minutes. Oh, yeah. How many of you just started thinking about buying multiple cars? Wait a minute, I do that a lot. Why is that? We used the example earlier about cleaning up a park, right? More people means cleaning up the park faster. Well, video editing, conversion, we're going to take each part of that video and turn it from one format into another format. We can divide that. Okay, video is a stream of bits. So if we have 16 cores that can work on that simultaneously, we can do it 16 times faster-ish. Probably 15 times faster because there's going to be a little overhead for kind of managing the workers, right? You need a manager. Yeah, so let's say 15 times faster than any single core could do the entire job. That's pretty legit, right? So that would be an example of something that a machine like that would benefit us. Now let's say you use your computer mostly for writing papers, browsing the web, and playing video games.
Useless.
Yeah, it's useless. You would have been better off buying a more normal computer with a ridiculous monitor for viewing your video games, right? Instead, you spent all your money on the computer and had to go with the budget pleaser monitor, which is the part that you actually are going to use. It's like, well, I only had enough money left over for this 17-inch refurbished VGA monitor with a 30 hertz refresh. So a lot of times consumers make poor decisions when it comes to computers because consumers, the average consumer, buys things based on marketing. Bigger the number, the faster it is. Examples I like to use is when you go into like places like Best Buy, and they do this less now. I think consumers are more educated now than they were. But in the early days of larger hard drives, you would go into Best Buy, and it wouldn't be a, probably back then it was let's say like a 100 gigabyte hard drive. That's not how they'd list it. They'd list it in bits. This is a 1.028 trillion bit hard drive. And they actually put the zeros. You can't read it, must not be able to fill it. Right? People would buy that. Sometimes you'd actually buy a smaller hard drive than the one next to it because of the marketing. You thought it was bigger. Does the average person know what the difference is between gigabytes and megabytes and terabytes? Becomes a little dangerous, right? Because you could still go into the store and buy a 750 gigabyte hard drive or a 3 terabyte hard drive. Now, maybe an average person can decide, 3 terabytes is probably bigger because it's kind of a small number and it's got a new suffix, so it's kind of, it's not in the hundreds. Yeah, it's more expensive. It must be better. How does that translate into how many of you have bought a Wi-Fi router before? I'm a big advocate of training use so computer science people don't get taken advantage of at stores. You go to the store, there's like 4 routers sitting next to each other. Each one has the router, the Linksys Economy and the Linksys Home and the Linksys Enterprise, and each one they add $75, right? So in the end, you got a $175 router versus a $30 router. Which do you buy? Well, if you're a college student, you're probably buying the 30. Especially since you only need to cover a dorm room and you're going to hide it under your bed. Right. What's this?
Then you get caught by the school.
Well, that's why you're hiding it.
No, I mean for the IP. I had one in my room freshman year.
Yeah.
I sent out a mass email listing all the names of the Wi-Fi routers, and if we didn't take them down, they shut down the internet in our rooms.
Okay. Were you broadcasting your SSID?
No, it was just in our room.
Well, no, I get it. But if somebody was standing outside of your room, would they have seen your Wi-Fi signal?
Probably.
Well, you got to turn that off. You don't want to broadcast your SSID. You want that to be hidden. That way somebody has to really be looking for them. You have to do a broad scan. Okay? What you also want to do, not that I'm saying, if you happen to get a Wi-Fi router today, not that I'm saying, they already have a record of your computer being on their network, right? And your network card has a unique identifier on the network. You know what it's called? MAC address. Okay? Most routers today have an option where you can clone a MAC address. So you can go in, put your Wi-Fi router in there, don't broadcast the SSID, and enable the option to clone a MAC address and put in the MAC address of your PC. From their perspective, that new router looks just like your computer that was sitting there forever and ever and ever.
It's also how you ever get a new IP if you need one.
That's true. Yeah, if you ever get banned from a game for cheating and they blacklist your IP, what you can do is you can clone a different IP address on your router, and then then when you reset the router, your cable company or whatever will hand you a new IP address because it thinks you have a new computer. Otherwise, you're always getting the same IP address, more than likely. Well, now your IP address isn't blocked anymore. So you can start cheating again. Just saying. So if you were trying to get around what you shouldn't do, don't break the rules. In fact, I really can't even come up with a great reason to have a. Is there a great reason to have a Wi-Fi router in your room? There's definitely a good reason to have a router in your room, a hardware router, just so you can have multiple things plugged in at once and have them have unique IP addresses. So if you do that, definitely do what I just said. So that's not hurting anybody. Okay, that router's doing all the work. It has something called a NAT, network address translation, and you're not hurting the network at all. You start putting radio signals into the air, now you're possibly degrading the experience of other people and that kind of stuff. But the other way, you're not hurting anybody.
Does Wi-Fi and wireless go to the same internet?
Wi-Fi and wireless go to the same.
Wireless and wired. If you hardwire into the wall.
They use the same internet bandwidth, but they might be going through, depending on which wireless you're using, they might be going through a different list of restrictions for blocked. That's why on some of the Wi-Fi networks you can get to certain things that you can't get to on others, because they're blocking different things. They have something called reflexive access lists, or whatever the modern day version of that is, where it detects the type of activity you're doing, the type of place you're going to, and it may or may not allow that. So, for example, FalconNet, and this is actually kind of interesting. FalconNet blocks some things that ResHall didn't. You would think that Falcon, which is the completely open network, would have everything open, and it does. But there's certain things that Falcon blocks that FalconNet does not. Very interesting. So sometimes when you're trying to do a software update on something, you have to start off with Falcon. By the way, here's a hint. How many of you have ever tried to do an update to something in your dorm room and it didn't work? Like it just kept failing over and over and over again? None of you? Probably a lot of you, right? Okay, here's a hint. If you have the option with the same machine to do wireless and wired, start off with wireless, so unplug the wired cable. Most computers are set up by default where it will pick a wired internet connection over a wireless internet connection automatically. You can change that if you want through the in the options, but by default, it'll always pick a wired over the wireless. So unplug the network cable from your computer. Start the update over Falcon. It'll be slow, but it'll probably work. Because what it's trying to do is it's establishing the initial connection to get past the initial socket connection to the update server. Once it starts updating slow, plug the network cable in. It'll flip over to the wired, but it'll already be past the initial check. So it'll just hand over the socket. And then you'll be able to download more quickly. See? The more you know. Man, I hope Newhouse doesn't get a hold of this video. I'm not condoning any of this. I'm letting you know as interested consumers. It's a learning experience. That's right.
Or you could just use a VPN and get around everything.
Well, that's true, but you're going to need to have a host for it.
Yeah, well, there's a bunch of.
Oh, like sites that you can most of them probably charge.
There's some that you can get away with.
Because we did that when I was an undergrad. They actually blocked communication between dorms. So, like here, if you're on campus, you can share stuff with other people on the same network, right? They don't block that. Well, when I was an undergrad, they did. Each dorm was behind its own firewall. This was a physical, it wasn't one building like this. It was a bunch of physical things over, a bunch of neighborhoods. It was a big, big campus, University of Illinois. And so what we did is there was a central server on campus called UXB. And this was a Unix server that everybody had access to. Okay, so no matter what dorm you were in, you can go to the central location. So what we wrote is we wrote a Java server that lived on UXB, and it accepted incoming socket connections. And we'll actually talk about that in this class with inter-process communication, so this is a foreshadowing thing. So it accepted incoming communications, and what that did is, so if what a firewall does is it blocks things coming in, but you could open the door going out, right? So your house has all the most expensive security stuff in the world enabled in it, and you go and open the door for somebody, the security is useless, right? Okay, so what we do is, if I wanted to share, so let's say David and I are in different dorms, we want to share some file. Back then it would probably have been MP3s or something like that. No, like this is before that. Yeah, this is when those things didn't exist. It's like I want to send a song to my buddy across campus. Okay, so what we would do is we would each establish a connection to the UXB. UXB would now have an open door to both of our dorms. That's that one server. It would then connect those two, creating a pipeline. So we essentially made a phone call to each other through the internet. And then we can then, one of ours would be set up as a client, one of them would be set up for a server. So if I was sharing this thing with him, once we had the connection, I would be able to say, send this file to this other person connected, and it would send it up through the open connection because we both had opened the door. So it wouldn't have to go through the firewall because we had opened up the communication channel. So we both opened it up here, and then we connected the two up top. See, that was a little bow, like that. See, that's what real computer scientists do. Well, real computer science students. That's what real computer science students do. You guys are managing your fantasy football and... Come on, get geeky! All right. What were we talking about? How do we get off on that? We're talking about CPUs and...
So then you're off about 30 minutes of how to get around firewalls.
Well, the firewall's only at the end.
Well,
Okay.
Just
Yeah, don't get taken advantage of at Best Buy. And the thing is that the employees at Best Buy aren't trying to take advantage of you. In fact, in many cases, they don't know. Okay, we have an employee from Best Buy sitting in here, right? Right? And I guarantee he only knows a little bit. And what he doesn't know, he's going to lie about. So, oh yeah, that printer does 700 pages per second. Yeah, it's full color. Oh, you'll never run out of ink.
Magic.
And what does Grandma do? She buys it. It's like, well, 700 pages a second is better than what this one says because it actually printed it on here. And it's less money too, honey. So they buy it. Just stupid. Aren't you going to be Geek Squad?
No.
Oh, you weren't good enough for Geek Squad.
No, there's no
See, Geek Squad goes to your house and lies to you. So it's a higher level position. I mean, you have to earn your badge of deceit. All right, we'll pick up from there on Friday.